pyramids and cones. You could have right pyramids or oblique pyramids, again, just meaning, about how the shape of the figure, whether it's like slanted or normal, you're going to do the same formula no matter which one you have. Same for right cones and oblique cones. The volume formula is 1/3 the area of the base times the height. And this comes from the fact that your volume of a cylinder that has the same circular base as these cones could actually be filled 3 times with this cone of the same dimensions as this cylinder. So that's where that 1/3 comes from, that each cone is 1/3 of the volume of the cylinder. The B is the area of the base, and H is the perpendicular height of the pyramid or cone, depending on the figure you have. So here we have a square pyramid. So the base of it is a square. And remember, we used slant height the last week, the height of that slanted face. This week we're using true height in our formula. It's the H rather than the L, and that is the height that goes from the point and makes the right angle with the plane of the base there. So this is the height we're going to be using. And the volume formula for the pyramid and cone is just 1/3 area of the base times the height. So for us in this image here, the B, the area of the base, is 16 squared. So just squaring 16 is 256. And the height is the 15. So we want to do 1/3 of 256 times that height of 15 to get our volume. Giving us 1,280 feet cubed. The next one, we have an oblique cone, and the height, when it is oblique, often will be drawn outside. What you want to do is you want to look for the right angle marking that leads you to find the height of the figure. The radius is 10. So the volume, again, 1/3 the area of the base times the height. The area of the base is pi r squared because it is a circle. And the height is 16. So 10 squared is 100. 100 times 16. 1,600 divided by 3 pi. This would be how you would write this in exact form. Centimeters cubed. And if we want to then put pi in to get a rounded answer, you would need to divide, the 1,600 by 3 times by pi will give you 1,675.5 centimeters cubed. And here we have one where we're working backwards. They have given us the volume, 200 millimeters cubed, and we have the height, and we're looking for the radius. So 1/3 the area of the base, which is pi r squared, and we don't know the radius, so I'm going to just call it r, times the height equals to that volume that they've given us. So we need to simplify and solve backwards and solve for the radius. So what I'm going to do here is I'm going to write this as 10/3 pi r squared equals 200. And I'm going to begin solving by multiplying both sides by 3/10. I'm multiplying by the reciprocal so that this fraction value will cancel out, leaving just pi r squared. So 200 times 3 divided by 10 is 60. And now we're going to divide by pi. You do need to get the r squared alone before you square root. So I have divided by pi, I'm getting about 19.09859. And now we're going to square root this. So I'm going to square root my answer. Giving me 4.37, so about 4.4. And that's millimeters for that radius. Now, if you're having to use decimals, you might have to round as you go, and Pearson will tell you where to round as you're working. I have seen that, where they're telling you at each step a location to round to so that you're getting the value that they have for their answer, and you can have a matching value. Let me know if you have questions.